Okay, I know I promised we'd start the next video or start the next lecture with the next video, but I just remembered I've got this other example. It's pretty straightforward. This is about as straightforward as I can make one of these. Find the area between these two curves. Right. So let me show you how to set up the area real quick, and then I'll just show you the solution then out of my notes for the X bar and the Y bar. So I'm going to make this pretty short. So the area of this guy. So if I try to find the area of this guy, well, again, we talked about on the last lecture that you're going to integrate two integrals. The area is going to be just simply the integral dy dx. Okay, and your limits are going to be the bottom function. So this is going to be one. I should have left more room. 1/4 x squared. And the top one is just going to be x, this linear function, and the bottom is this parabola underneath it. And then the second integral then, the outside integral, is going to go from, in this case, it's going from 0 out to 4 foot on the x-axis. So we'll just call it 0 to 4. Okay. All right, so if we do this real quick, I'll write this next line bigger. I apologize, this is too small to read. This is going to be the integral from 0 to 4. I'm going to integrate dy. Well, that's just y. And y is going to be evaluated from x on top. On bottom, it's 1/4 x squared. And then I'm going to integrate with respect to x next. Okay, let's evaluate this let's evaluate this notation here. We've already done the integral. Let's evaluate the value. So the area is going to be the integral from 0 to 4. I'm now going to integrate, I'm going to take y evaluated at x. So it's just going to be x minus y evaluated at this value. It's going to be 1/4 x squared. So I'm now going to integrate this with respect to x. So now I'm going to integrate this with respect to x. It's not a hard integral. It's just a polynomial, second order polynomial. So here I'm going from 0 to 4 on the, I'm going to go ahead and do the integral. So I'm going to integrate this with respect to x. This is going to be x squared over 2 minus, this is going to be 1/4, and this is going to be x cubed over 3. So it's going to be minus x cubed over, and it's going to be 4 times 3, so it's going to be 12. And that's going to get evaluated from 0 to 4. You plug in 4, and you plug in 0, you're going to get 0 here, right? Well, if we plug in the 4, I have written down here a number, 2.67, and if we'd carried our units around, we would get square feet. That's area. So in these, again, this guy goes from 0 to 4 feet on x and up to from 0 to 4 feet on y. So this area is going to be in square feet. And this is how you would find that area. All right, so remember, x bar then is going to be the integral from same limits as what you saw in the area, 0 to 4, my x limits. The y limits, it's going to go between the two y functions. So it's going to go from 1/4 x squared up to x. I'm going to integrate for x bar. I'm going to integrate x first with respect to y and then with respect to x. And I'm going to divide that by this area. I'm just going to write a so I don't have to write 2.67 feet squared every single time. You can write 2.67 feet squared every time if you want. I'm going to save a few characters. Now, what I would suggest is if you're following along and you want to stay engaged, pause it right now and see if you can evaluate this. Right? And then I'm going to show you the solution when we get done here. Okay, but go ahead and pause it. I'll wait. Okay, have you got it there? All right, so let me show you the solution. This is of my notes. This is actually pretty clear. Integrating x with respect to y. Right, so this just becomes x times y, and for y, then I'm going to plug in x and this guy. So it's going to be x times these. The difference of these limits here, since it's just x times y, and y is going to be these guys. And then this is going to get integrated with respect to x. Right? And here I did write my area down. You're more than welcome to just keep writing a. Okay. Now I've skipped some algebra here. Right? It looked like I was in a hurry when I wrote this out. So now I've got x squared minus x cubed over 4. So if I integrate with respect to x, x squared, that becomes x cubed over 3. And if I integrate x cubed over 4, I end up with x to the 4th over 16. And this is going to get evaluated from 0 to 4. And you calculate out, I end up with 2. Hopefully you got there. If not, pause it here and look and see if you can kind of figure out where you messed up. All right, are you good there? Okay, and now what I want you to do is go ahead on your own and try to set up the y-bar integral. Go ahead and pause and try to set up the y-bar integral. Okay, you got the y-bar integral. And if you want to go ahead and work it out, you can. I'll go ahead and show you the next line here. So this is the next line. This is how I set it up. And then go ahead and do the evaluation. Pause it and see if you can get down to an answer. If you want to pause it here and see if you can get down to an answer, go ahead. All right, you got an answer? Let me show you what I've got here. So this is what I've got. Okay. So again, a nice solved example to show you. But hopefully you've already figured out at this point, watching me do these problems is only so helpful. If you're actually doing these problems, that's infinitely more valuable. That's the reason I want to go ahead and, that's why let's just do this. We can do this real quick. We'll call it bonus. I'm going to attach it to lecture 17. And I promise in the next video will be lecture 18 where we talk about composite bodies. All right. Have a good one.